Okay, I've started the recording. It is hi, good morning. Good, okay, good evening. Right. Let's check. Yeah, good. Sure. Okay. So, guys, just confirm in the chat whether you can see my screen or not. Yeah, good evening. So, yeah, yeah, okay, visible, fine. So, I have intentionally mute your microphone and and turn off your cameras because there may be disturbances, right, between the call. But anyway, whenever you have some question, just put everything in the chat. Like in the last 15 to 20 minutes, we will discuss your doubts. Okay. And meanwhile, if you want something, so I will repeatedly check after 20 minutes whether you guys have some doubts. And meanwhile, like within the session also, time to time, I will ask ki, if you have some doubts, you can like ask the doubts now. Okay. Then I will unmute it. Okay. Yeah, I can talk with Hindi, but anyway, so will it be comfortable for everyone? Because I don't know whether everyone is everyone understands here Hindi, right? So can you just let's do a poll or something, or okay, let's just stick to English for now, right? Because anyway, you are doing higher studies, you have to stick to English, right? It's not like throughout the whole run you will be talking in Hindi. Okay. Hello, hello. Okay. So let's just go to the presentation. What's happening? Okay. So guys, you can hear me, right? Just anyone just reply in chat. Okay. And yeah, the recording will be shared with you, I guess. The recording will be there. Okay. Fine. Right. So, okay. So, so this is a session of this joy of computing using Python, right? Just 1 minute. Okay. So this course is on joy of computing using Python. So broadly, what we will learn is how the uh, programming language Python works. Okay, and what we can do with it. That's it. So throughout the course, the objective is to build useful applications with Python. Okay. So yeah. So my name is Prasenjit. So I'm a PMRA fellow at IIT Kharagpur. So yeah. So this is my introduction. So you can anyway you will get the slides as well, right? The slides will be shared with you as far as I know. So you can open up these demos where you can see some of my research, right? And my home page is this, so you can reach out to me if you have any doubts. Okay, and I worked on AI and ubiquitous computing broadly, but in depth I work in distributed sensing and networks. So it's basically what we can learn from small sensors that is distributed across a area or a region, right? So this is what the research area I am working in. Okay. Okay. So just to recap your week one's content, right? So in week so yeah, in week one you are learning Scratch, right? So why you should learn Scratch first of all? So it's developed by MIT and it's useful for teaching children how to code. Okay. because they don't have to memorize keywords and all. There will be the interface is so easy that anybody can understand and basically code. Okay, let me just okay. Okay. Yeah, Dev, just wait for some time. I will unmute you if you have some doubts. Okay. Okay. So why you should learn this? Why you should learn Scratch? First of all, it's a tool that is built to that is actually built keeping in mind the initial learning steepness of the, or basically the initial steps of learning how to code. Okay. So it's meant to make that part easy. So what are the main goals we have to learn as, let's say, undergraduate students, right? So how the overall sequence or overall execution sequence of a program that we need to understand from scratch, the overall control flow, or whether we can let's say play around with the control flow of the program. So usually what happens, the program starts from the beginning and keep on executing the instructions line by line. Okay. And at the end there will be an exit command which basically terminates the program. Okay. Or there might not be any exit command. Whenever it reaches the end, it will terminates. Okay. And then there is a concept of grouping, code grouping, or the code that I want to use repeatedly, right? So that I can group at some time, and let's say I can use that group of code anywhere in any of the applications I'm developing, right? And lastly, the object is to like looping. So for example, I want to do a task repeatedly, right? So I want to run or execute a set of codes repeatedly. Let's say I want to count how many apples are there, right? So the pseudocode, or how we can think of counting apple problem is like this. I have to identify apple first. Let's say there are a bunch of fruit. Okay. So I have to identify apple first, pick it up, add 1 to my counting estimate, right? Let's say the counting it starts from 0. So after I detect some apple, I pick it up, I add I plus 1 to that counting variable I'm tracking, and then just let's say put that apple somewhere, right? Somewhere where I'm not picking from, right? So that repetition doesn't happen. So the pseudocode looks like this: loop, identify apple, increment 1 to the counter or the counting variable, and then just like put the apple back to some place, right? And then pick up the next apple. So this loop will continue until all the apples are complete, right? So you see there are two three segments of code that is being repeated over, right? Over and over. So that's what we meant by looping, or repeating some part of or subset of instructions. So the main concept we had to learn, or we have to basically grasp, is the how a program executes, what is the control flow, or how we can modify its execution, how we can uh, how we can code reusable blocks of program, and lastly how we can execute a particular program over and over, right? So let's just and this interface looks like this. So you can, if you don't have the if you don't have this IDE, so it's an integrated development environment. So you can download it from this site, right, and install it in your system just to practice. Let's say if you are a very new to programming, right, like as far as I know, most of the students here are from first 2 semesters, right, maybe third semester, not more than that. uh, yeah. So if you are new to programming, which is most likely the case, is you download this scratch IDE, try to understand the execution and control flow of a program, and it will be staying same over different languages as well. So any programming language you pick, which is a scripting language, right, like Python, C, and let's say Java has some differences, but anyway the overall concept is same. Okay, what we can do with Java is what is also the case that you can do with Python. Okay. Yeah. Maybe some tasks will be harder to do in Python. Yeah, but harder to do in Java is some parts, right? But anyway, the same capabilities you have throughout all the scripting languages. Okay. Now, yeah, I will like highly recommend that you download this IDE and practice. Okay, like for initial few days. Now let's just to recap. Let's like recap your week one's content. Right, we will just do three tasks that broadly groups what you can learn from these three things, like sequence flow, control flow, code groups, and looping. Right. Let me just close out from the presentation and open Scratch. Wait, Scratch. Yeah. So this is what Scratch ID looks like. Let's delete all these code segments. Yeah. So what are the things you can do, or what are the constructs you have in this programming language, that is Scratch, right? One is this motion. So there are always you see there will be a spirit in this case, or some object that you want to program. Okay. So for this case, let's say I choose this cat. Okay, I can also delete this, add a new character, right? Let's say a bear, right? Now he's the basically the what so what we will be coding, we will be directly reflecting this bear's behavior. Okay, let's not go with a bear because it's too big. Let's go with a chick. Okay, fine. So now what we can do with that stick is we can control its motion. All these things you see, these are all, no, sorry, this these blue ones are controlled. So how you can control its movements. Okay, let me just check how many participants are there. Okay. So there are 161%. Fine. Okay. So for movement, we can do all those things. So I can say if I click this thing, it actually executes this block and move the tick by 10 steps. Right? Let's say I want to turn it 15 degree. I want to turn it anti-clockwise 15 degree. Let's say go to some random position. You see, it's going to some random positions, right? Now go to X, Y. See, this clicking this random position thing also changes these values. Go to X, Y. Right? Let's say I want to go make it go to 0, 0, right? And I double click on this. You see, it's going to the center of the screen, right? So all these code blocks, they execute a piece of code that reflects the behavior of this chick, or the protagonist in this case, right? Yeah, point to direction 90 degree, fine. Point to direction 45 degree. Oh, sorry, 45 degree. Yeah, like this. Okay. Okay, fine. Now looks. So here you can specify what the chick would do. Okay, so let's just reset it to reset. Okay, it's already 0, 0. Wait, position look to 0, 90 degree. Yeah, let's just make it as it was earlier, right? Right. Now I want to uh, make the bird say hello. Okay, so if I just double click, you see it says hello. Now see, these code blocks are actually like something it does for once, right? Let's say I want to execute, let's say I want to go to 10 steps, then say hello. uh, let's say move backward, go to 10 steps again, and say bye, right? Now to do this, I have to manually go to all those code blocks and modify their, let's say, values, right? Let's say I want to go to the reverse direction, so I have to change the point of where the chick is looking and then go move 10 steps forward, right? So if I want to do that thing here, I have to manually scroll over and over and then click, right? And it's very hectic. So what I can do, this is the code editor. So where you can basically drag code blocks, and those will be executed sequentially, right? So the first code block will execute, then the next code block, like this until there is no code block, right? So for example, I want to start from here. I want to move to 100 steps, right? Then I want to come back, right? So I have to change the rotation or change the point of direction, right? So I want minus 90 degree reverse. So I will go forward and then I'll go backward, right? And then let's say I just copy this. Now to all of them to work, what we have to do is we have to attach them. So see, these are kind of Lego blocks, right? They will attach with each other, right? Now this one, let's say I want to start from here. Now if I double click on this whole block, you see what happened? Okay, let's see what happened. So this is how you debug. Okay, let's make it normal again. Yeah, I double click. What happened? Okay, now this is what we called a bug. So what we intend for is to go forward and then come backward, right, at the same position. But let's say let's just make it to 90. Yeah, let's say what should happen if I just vaguely run this in mind, right? It should move forward 100 steps, rotate rotate 90 degree backward, and then move 100 steps again, right? Yeah, okay. So we have a query. Wait. But we just unmute. Yeah, you can, I guess, you can unmute, right? Guys, check if you can unmute.
Yes, yes.
Okay. Now, if you have any doubts, just raise your hand, unmute, and speak. Okay. And don't like create any noise or something. Yeah, so that somebody has any question. Yeah, you can just unmute and speak. Okay. Okay. Where is the scratch? Yeah, here. Now, see what should be the usual output for this. Hello.
Hello, sir.
Yeah, yeah, I can hear you.
Sir, I was like coding on Scratch and I saw pink colored blocks named my blocks. So I wanted
Uh-huh.
to ask you about them.
Yeah. So you see the presentation, this one, code groups or functions. This is what code blocks means. So I'll just come to it. Okay, just wait for some time. I'll just
Okay,
like describe the overall idea of Scratch to everyone, and then I will show how code blocks works. Okay. Okay. This is
okay, sir.
this is this is what you are saying, right? This my block, right?
Yes, sir.
Yeah, this one. Okay. I'll just discuss it after some time. Okay, just let's continue. So
Hello,
what is the problem
hello.
here? Yeah. Okay.
Sir, can we get the video recorded lecture of today's session?
Yeah, you'll get it. So in Teams only you can access the like recording.
Sir, how can I get it? Is there
So
any email from NPTEL or any website what
uh,
you will
yeah, so
send us?
I will upload it to YouTube, right? And what I can do is I can ask the NPTEL team to share it with you. Okay.
Sir, which YouTube channel?
So I will upload it to my YouTube anyway. So
Can you think, sir, can you tell me what is the name of your YouTube channel?
okay. Let me just open it up once. Uh, so it's my name actually. Uh, yeah, you can put this. So not a lot of videos has been uploaded here. I can put this one in chat. Chat. Yeah, I guess you can come to this link. Okay. Okay. So
Thank you, sir.
yeah, let's continue with the topic, right? So we are what we want to get is I want to go 100 steps forward and then rotate and then go 100 steps backward, right? So doing this doesn't help, right? So what is the problem? The problem is, so in these cases what we have to do, we have to break the problem in small parts. Okay, so let's see whether we can go 10 steps correctly. Okay, fine. Let's drag another block 10 steps which is separate. Okay, not with this. Now if I double click this, it goes to 10 steps. Fine. Now I copy pasted another block. Now if I double click, yeah, it goes 10 steps, like basically 20 steps, right? If I copy this, it gets to 20 steps. Now if I copy this whole block 10 times, another, how many times? 1 2 3 4 5 6, right? And then say 7 8 9 10. So this whole 10 blocks represents this move 100 steps. Okay, now it's, yeah, now if I click on this, you see it directly moves here, right? Now the problem is we want to see an animation also. It moves 10 steps, then it wait for some time, it moves 10 steps, right? So our brain's response times is 1/10 of a second. Okay, so if something happens beyond, like below that time, so you cannot like realize it. Okay, so because this whole code block is executing at once and there is no delay in between, so we what do we see? We see a basically a, you see, we don't see the tick moving, right? It appears to be appear directly at the destination, right? Yeah, but actually it's happening so fast that we kind of have that effect. It appears directly in the destination. So what we can do to animate this is add a wait block. Okay, so this can be found in control. Yeah, control, this block. So what I can do, I can let's say not 0 second, I can do a 0.5 second or 0.2 second, and then copy this thing. Let me just yeah, let's just make multiple copies of it, and control C control V works, so you don't have to drag like these blocks multiple times, right? Now something like this. Now if I run this, just take the chick back here. Okay, now if I run this, you see the effect, right? So for first 3 steps we get the animation effect going, but then because there are no more animation here, like no more delay steps here, that's why we just then the duck jump to directly at the destination, right? So you have to put, yeah. So this is what you do for debugging. Keep breaking this whole thing into small chunks, right? something like this. Now, what's gone wrong that we don't go backwards? That we have to check. So the direction part. Okay. Now let's copy another block. Oh, sorry. Yeah. So now our movement 100 steps. Sorry. Wait. Yes. So the bugged code was this, and now we replaced this one step with all this move and wait command, right? Now at least it works going forward, right? But to this it goes forward. Fine. Now just let's keep this whole thing a copy, like for bit later use. I will show why. Okay. Now I want what I want to do. I want to rotate, right? Rotate backwards so that the chick looks in reverse
हेलो
direction. Yeah,
सर
yeah.
सर हम ये पूछ रहे हैं कि पाइथन में इसका काम क्या पड़ेगा जी जो पढ़ रहे हैं जो जो आप
हाँ
बता रहे हो ये इसका इसकी जरूरत क्या है पाइथन
हाँ, बिकॉज पाइथन में इसका ज़रूरत नहीं है कुछ, ठीक है. सो what you are learning now is the general workflow of a program. Now, after you know this, key, okay, this is how code execution works, right? Then later on, you can borrow from the same idea and like implement codes in any language, not necessarily in Python. Let's say what somebody asked, right? This code block. What is code block? So code block basically represents a function. In Python, there will be a function. In C also, there will be a function, right? So this function, this concept is important. And later on, you can learn any language. Those concepts will be transferable. So Scratch would help you understand the basic blocks that programming languages works on. That's the main. See in the presentation also, right? Our goal for this part is understand the sequence of program flow and what we can do to modify it. What are this code block? What is this thing? And looping, right? So we'll reduce this code. What we are currently doing, right? Reduce these codes to let's say 4 5 lines. But now you see because I am writing unoptimized code, it's going what it will go, it already goes to 1 to like 20 instructions, right? So later on when code optimization will come, we'll understand which blocks to use to optimize which part of the code, right? And you can use the same idea, you can use the same idea in any languages, not like C, Python, JavaScript, anything, Java also. Okay, now you understand why you are learning these things, right? Anyway, so we'll just quickly finish this part and move to Python. Not a big deal. Okay. Okay. Now see, at this point I can correctly make the chick walk 100 steps with animation so that I can see. Okay, it doesn't jump directly to 100 step, right? Now I have to rotate it. So rotation, let's see motion, how we can rotate it. Yeah, we can rotate is this way. Now the problem is if I rotate this and then move, you see it basically bends the rules of physics, right? A duck cannot walk when its head is down, right? So this is not a good code. Hello.
Scratch pen.
Huh?
Scratch.
Yeah, you can repeat once.
ఫోన్ అయినంతండి అక్క ఫోన్ అయినంతండి అక్క
Hello.
ఫోన్ అయినంతండి
Wait.
నేను
Okay. So you guys are muted. Anyway, so now the problem is this is not logically true, right? So what we can do, yeah. So I want to flip, rotate it to left right. Yeah, rotate, switch rotation style, left, right. Direction, but it does. Left, right, doesn't rotate. Yeah, so point towards mouse pointer. So this is what you can use. So because my mouse pointer will be over here, right? And see, there is no code block to rotate it like horizontal, right? So what we can go with is point towards the mouse pointer, and when my mouse pointer will be always here, right? So after it reaches to the 100th step, it will see, okay, my mouse pointer is in the left side of the screen, so it will rotate in the left side. Now I can use this block here, rotate towards the mouse pointer instead of this rotating minus 90 degree, because what it does, it basically rotates the duck such a the chick such a way that its head is in the earth direction, right? So that doesn't make sense. Okay, and then what I can do, I can use the same code block, stack it below it. Oh, sorry. Yeah, see, now to debug this part of the code, what we have to do is break the whole code, and what we found, the problem was we don't have any delay in between, so it appears to be directly jumping to the destination, and this direction minus 90 degree, it applies a rotation such that the duck's head is upside down, so it doesn't gel with the physics, right? Yeah. And then this moving next 100 step is fine, but then there is no delay, right? Now let's run this. Wait, let's run, point to this direction first, come here, run. Oh, now see what happened. This is an unwanted behavior. You see, the duck goes this way and then move to a angle, right? That because my from the duck my mouse pointer was at an angle. This is really interesting, right? Now let's keep my mouse pointer almost similar, like horizon, almost basically in the same line as the duck, right? Let's click here. Now see. Yeah, so we have done it, right? So to debug this line of a code, these three lines, we have to write all these things. So, and how it works in a sequence. So it start executing from the first line and then goes to the next line, right? Like last line, and then stops there. So if I want to move, make the duck move to the same direction again, what I can do, I can use this point direction 90 and put it at the end, so that after returning it just move to the same direction again.
सर
Anyone?
यस क्या आप हिंदी में
Yeah.
बात कर सकते हैं
But see, I can always talk in Hindi, okay, but whether it will be helpful for everyone, because there are some people who are joining, let's say, who don't speak in Hindi, right? So I have some friends who don't speak in Hindi. So because it's an like general class, anybody can join, and it's everybody is joining from the whole current country, right? So some people are not like that much aware, or that are not very fond of Hindi, okay? So they find it hard to understand, so we'll just stick to English. If you don't understand anything, just ask me directly. You can ask in Hindi, okay, and I will try my best to let you to make you understand whatever your doubt is, okay? So you can ask questions in Hindi, but anyway, for the general audience I will go with English, okay? Okay, so now the objective, let's run it again, and I will keep my mouse pointer almost at the same direction or same level of the duck. Okay, I am executing it. It's going, coming back, and then yeah, So my objective is done, objective is complete. So this is the wrong code, so I will delete all those code. Yeah. That code was not running anyway. Yeah. Now what part is done? Let's go to the presentation. This part is done, right? This program flow. Now if else, let's not cover it. If else, let's say we only cover in Python. Let's go for code blocks and loops. So first we will go for code blocks and then we'll go for loops. Okay. If else, so just to contextualize this, if else is when you branch decisions. Okay, or we have a branching decision. Let's say if my if I have 10 rupees, I will go for a chocolate. If I have 100 rupees, okay, then let's say I will go for a dinner, right? Something like this. Okay, or let's say if I have one pen, I will buy another pen. If I have two pen, I will not buy anything. This type of branching, whenever you have to make a decision, so there will be a if else block. So in Scratch also there is if else block, but anyway, because we are just learning Scratch to like build some of the concepts of code programming, we will just not touch upon it. We will touch it on the Python part in detail. Okay. Now let's go for code block. So one participant I guess asked what is code block, right? Where is Scratch here? So let's see which part of code I can group together and kind of name it and reuse it. See, this whole code move 100 steps and this animation and all this up to this, it's actually repeating here, right? It's repeating at the bottom. So I can, if I can put it in a, let's say in a separate box or a separate this kind of instruction, then I can only use that instruction twice or that function twice, or code block actually. Let's refer to as code block. So if I can name this whole block of code something, I can only call that block and all those instructions will be executed, and I don't have to write all those steps. So the see now how many lines it has. These are 20 lines. Next these are 20 lines, 1 and 2. So it's total 22 lines. 22 instructions are calling, right? Now if I want to optimize, yeah.
Hello.
Your voice is breaking. Hello. You can just repeat if once. I didn't get your question. Hello. Anyway, just whenever you are in a good network, then just unmute yourself and say it again.
Sir, can you speak little more louder?
Okay. Now you can
Actually, we
hear
are
me,
not
right?
audible.
Okay. Okay. So you can now you can hear me, right? Just reply it in the chat somewhere. Hello.
Line
Okay. So not audible. Okay. Okay. Just let. Yeah. Now you can hear me, right, guys?
Little more, sir. Okay, now it's better.
Okay. So I guess it's some network fluctuation that is happening. Okay. So just tell me when I am not audible. Okay. Okay. Let's just
Okay, sir.
continue with our work. So we have 22 lines, right? So I want to reduce it to 14 lines. How we can do that, right? Or 15 lines, let's say. Let's see how we can optimize it. Let's just identify the repeating blocks. So and see, these same ideas will be borrowed to Python. So if you understand it now, you can easily understand the code flow of Python. Okay. Okay. Now, okay, let's just yeah. So this is the repeating code block, right? So what I can do, I can delete it. Oh, delete the whole block. Oh, okay. Oh, deleting is a pain here. I have to delete each block. See, this is a looping thing I am doing, right? I am clicking and deleting. That's really inefficient. Now let's go to code blocks. Make a code block. Let's name it move 100 steps. And let's say with animation. Oh, sorry. Animation, right? Now how it is different from the inbuilt code block that is there, move 100 steps, it adds the animation part, right? Okay, so now we have a, oh sorry, yeah, yeah, now we have a code block. See this define thing. So Python, in Python we define functions with def. Okay, so def would work as this code block. Now you see what I am doing, I am attaching this thing below this definition. So now what it does, it creates a block that is named this move 100 steps with animation, and define the set of code or set of instructions that will be executed whenever I am calling this. So whenever I will be calling this, it will execute this set of instructions. Got it? Now I can just,
Yes, sir, got it.
yeah, now I can just create 2 copies, the same code flow in between. Yeah, yeah, sorry, fine. Now let's bring our chick back to the initial position. Now if I run this, yeah, now you got the whole point, right? What code block does and how you can reduce the number of lines. So how it is helpful in practice. So I can always, so you will be saying, okay, the number of instructions that are being executed are the same, right? So first 10, these 20 steps will be there, 20 instructions, then 1, then 20, then 1. In total there will be 24 instructions, right? Or 22 instructions actually, yeah, 22 instructions. So the number of instructions that is being executed is exactly same. So how it is optimized? Can anybody want to try? Or me, do you want to try to answer this thing? Anybody?
Sir, it stores that commands under that block. All the
Yeah.
commands
So how
under
it is
define.
helpful? Yeah. So how it is, so for understanding purpose it is helpful. That is one thing for sure, right? So for understanding the earlier code, I have to scroll a bit longer, right? But for understanding this code, it's easy, fine. But in terms of hardware or in terms of optimization, it's not doing optimization in terms of number of instructions that is being executed, right? So the number of
Yes,
instructions is still 22, but how it is getting optimized? So I am saying that now the code is little bit optimized. So how it is more optimized? Just try once. So it's uh, so think. So what are the resources a program typically need? One is CPU, right? CPU executes the instructions, fine. And another thing it needs, what it is? It's the memory, right? So how much memory it will take to store that program in let's say RAM, or let's say whenever it is executing in cache, right? So let's say for RAM, so whenever some program is getting executed, it it basically goes to RAM, and then CPU uh, takes one instruction at a time and executes it. Okay. So now you see earlier there were 20, how many lines? 24 lines. But now there are how many lines? This is 20, 24, not 24. Earlier there was for 20, 20, 40 plus 2. So 42 lines, right? So now the number of lines are, these are 20, and then uh, 1, 2 means 22, 23, 24, 25. So now it reduced up to how much? So if I calculate the percentage, how much it get reduced, now it is 25, and earlier it was 42, right? So it's 59% of the earlier. So if I just do a 1 minus, oh wait, just it's actually almost 39, 41% around, right? Yeah. So the now the main benefit that I got by using this code block thing is my memory footprint of the program reduced up to 41%. So it get optimized up to 41%, right? Now let's optimize it further. So what we did till now is, yeah, we saw this code block, right? Now let's identify what is repeating here. Okay, what is repeating? This steps and this second, wait, this is repeating, this is a repeating structure, right? That is being getting repeated 10 times. Now what I can do, I can use a looping construct that basically executes a set of instruction like multiple times. So you can find it in control, this one, repeat block. So what I want to repeat how many times? 10 times. 10 times this 10 steps means 100 steps. So instead of all this, what I can do, let me just copy this and copy another wait statement as well. Yeah, let's just put everything back together. Now this whole thing actually represents this. Go here, another one goes here. Is it okay? Yeah, and now yeah, I want to go for 9 steps, and then at the end I want so exactly same representation would look like this. So this whole thing in this type in loop looks like this. So how many instructions are there? 1 2 3 4 5 6 7 8 9 10. So 10 move instructions, and how many wait instructions? 1 2 3 4 5 6 7 8 9 9. So what I am doing, see, 9 repeat of this block, and then last another one. So I can remove, or let's just keep it for now. I will create another code block, move 100 steps, steps, steps with animation loop. Okay, yeah, now okay, I have that block, I just put it here. So this function and this function essentially means the same thing, and I'll just copy this set of these two things, put towards mouse, and let's just drag it from here, put towards mouse, and then direction, yeah, this one, and then what I need, yeah, blocks. So I need this block. So I want to move, and then move again, and then go here, right? Now see the difference. This was our earlier implementation, this one, and now the same thing can be represented like this. Let's just put our code little upward so that my mouse will be, let's just put this back down. See, the main execution of the main code doesn't change. What changes is, first of all, I don't have repeating instructions now. I have a loop, and then I just use that block 2 times within my main program. Got it? So earlier, now we'll check both the programs. Just keep it. So this was unoptimized version. This was the optimized version. Okay, the check is in the starting line. Now execute the unoptimized version. Fine. Cool. Now execute the optimized version. Cool, right? So now see, this whole set of blocks can be deleted. Wait, let me just right click and delete the block. Is it delete the whole block? Delete block. Oh, deleting is a pain. Let me just delete it.
Why we can't delete together as a single one now?
Yeah, so I don't know. So this code, this editor doesn't allow you to delete multiple instruction at a time. So you have to delete it one by one. Just you have to as you add it one by one, right? Anyway, yeah. So the first version of the code was looking horrible, right? Now at least we have an optimized version. And how much? See, the number of instructions currently running is exactly same, 42 instructions. However, the code size is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the reduction is 9 by 42. 21 means almost 1 minus 0.21. Yeah, 79% memory has been reduced, right? Almost 80% memory we saved. Okay, now earlier let's say it was running on an, let's say for an example scenario, right? What happens if you reduce or if you optimize the memory footprint? Let's say you want to play Call of Duty, right? And now the new Call of Duty game wants 16 GB of RAM. So if they have optimized it further, you can run on a 4 GB machine, right? Given it has a good processor and a good graphics card, right? So by optimizing the memory, what we gain, we can still run the program on a machine that has low memory. Got it, right? Any questions like so far? So our first part of the talk is gone. So yeah, up till this we covered. So we'll move towards Python now, or how these ideas can be implemented for Python. Okay. So just ask if you have any questions for the IDE, how to install
This
it.
PPT will be shared, no?
Yeah, PPT will be shared.
Okay.
Okay. So do you have any questions? Anybody? You can just unmute and continue speaking. Like wait for uh, 5 seconds. Let's see.
Sir, using this scratch, whether any high quality videos or anything has been made?
Yeah. That's a really good question. So I want to introduce you to one platform. I use it personally. MIT App Inventor. This platform. So like you are asking, right, that what is the usefulness of this learning this language instead of Python, right? So this is the use case. Let's sign in with my account. Continue. Okay. So yeah. So what happens is you to build a mobile application, what you have to learn Android Studio. Android Studio works on Java, right? And I have like the Java. I don't like Java. Like personally speaking, I don't like Java. Okay, I have never seriously learned Java or used it anywhere. Okay, but I know Scratch, or I know how program works, right? So I can learn Scratch really easily. So what these MIT guys have done is how you can, so they have made this platform called MIT App Inventor, where you can basically drag and drop these elements, and this placement and stuff that you can also do anyway, and then you can write code which will be triggered whenever this button is, let's say, clicked, right? Let's do something with uh, it's do a say media notifier. Okay, notifier, and this is the screen. Now if I blocks, now this block will take me where this backend code would run. So this button 2, right? If I go to blocks, so yeah, so I can just ignore all this, or I can delete all of them. Delete. See here we can delete the whole code block, right? Now I have button 1, right? What I can do when the button 1 is clicked, save this empty screen now. Yes, when the button 1 is clicked, I have the notifier, right? Then show alert, right? And then what is the alert? I need a text box, so text. uh, yeah, this is the text. So what I hello, right? Now if I go to screen, that is screen, sorry, designer, this code blocks and designer. So when the button 2 will get clicked, uh, it should show a alert, right? So yeah, so when I will be testing this, so you can test it really quickly actually, but you cannot see it because I have to connect it to my phone. But anyway, whenever this button 2 will be clicked, a pop-up will appear which shows hello. So it's really easy to develop Android applications on this MIT App Inventor.
Sir, what you told, we have to connect it with the mobile app.
Yeah. So here, build, you can do a Android APK build that will directly export the APK, right? But you can also to let's say whenever you are developing something, you want continuous like debugging, right? So then you can do this either emulator or connect it via USB or this AI component that I use. It basically I have to scan a QR code and that app will be like Wi-Fi tearing will be happen. So I can debug the code over Wi-Fi. So my phone would directly reflect that. Yeah.
Sir, I have a question on Scratch.
Yeah. Go ahead.
Can you go to the page, please?
In the IDE or the
Yes, sir, the ID.
Mhm.
Can you run the code block again?
This one, right? Okay.
Yes. My question is, after going forward some steps, how it's turning back and moving backward? There
Yeah,
is no
this
turn
one.
command.
This one. Put towards mouse pointer. Right.
Mouse
So
pointer
put to mouse pointer
on
is this one. This one. This is the mouse pointer. You see. Now, why I did this? Because if I do this motion, rotate, or what you can say, this point towards direction, right?
Yes.
What I can do? I can do minus 90. That's how you put it backwards, right? But see what it actually does. Minus 90 will, okay. Minus 90 would also work, I guess. Okay, if I just let's test. I did it like wherever my pointer is in the left direction, so the duck could or the chick could move to the left direction. But anyway, I guess this would also work. This. So I'm just keeping this block out of the code block now. Now let's run this. Let me just put it in the starting position. Run. Oh, now also it works.
Okay,
So
I
earlier
got
what?
it.
Yeah. So
I
earlier
got
what
it.
was doing? Yeah. So fine.
Thank you, sir.
Okay. So this is a kind of application, right? That you can develop with Scratch and you can run it on your phone. Anyway. So this is really helpful, right? So learning Scratch would also help you in your like. So let's say you don't want to learn Android Studio, right? Then learning only Scratch would help you build mobile applications and let's say test any let's say research prototype or something in your uh, like without learning Android Studio. Okay. So anyway, let's close it. So the wait, let me just share you what is the site? Yeah, it's MIT App Inventor. Just share it in chat. Okay, fine. Now Scratch is done. So we'll move forward to Python. Okay. So now if you face any problem, you can write them up in the next session. In the first, let's say 30 minutes, we can discuss some of your doubts on Scratch. Fine. Now let's go towards Python. Now, so what we will be using? We will be using this IDE, okay, this Jupyter Notebook IDE to execute our code. That's kind of so in C, if you know C, right? So we have an IDE. It executes all code, all block, or basically all code instructions whenever you let's say compile it and then executes the executable, right? The let's say dot out file, right? But for Python, it's not a compiled language. It's actually interpreted. Okay, so the uh-huh.
Convert forward and mouse pointer.
Yeah, just can you repeat once? Hello. I guess type it in chat. Your voice is breaking somehow. Let me go to chat. Yeah, just type it here. I'll check it. Okay, so we'll be using this Jupyter Notebook IDE. So how it is different from a standard C IDE, a C++ IDE, just for example Dev C, right? So there you have to you have to compile the code, then you can run it. So the whole code gets compiled to an executable, and then you can run the executable, right? But for Python, it's an interpreted language, so it's not compiled. It's actually interpreted line by line. So first line get interpreted, second line get interpreted like this. So then we have some really cool debugging capabilities, right? So you can actually run a wrong code which is not supposed to work, and then the program will crash at that line where the error occurs, right? So it's really good to debug something. So for C, I have to compile it. It will throw a lot of error. Key. This line has error. This line has error. So it will throw all the error at once, right? However, for Python, it will throw only one error that is like at first occurred. So you can solve that one, and then let's say there are further errors down the line. So the interpreter will give you errors. Let's say whenever, let's say first 10 lines are not like they don't have errors, so they will run properly, and then the 11th line will crash. So that's the difference between Python and C. So it's a interpreted language. It's not a compiled language. Okay. Now, so why Anaconda? Anaconda is a manager. So manager, what it does, it helps us to manage libraries. So Python has a lot of libraries. Let's say for C. For C we have stdlib, conio.h, like studio, not studio, stdio, standard input output. Okay. Anyway, so but anyway, sometimes people at whenever they are hurry, they call it studio. Okay. Um, so this manager, what it does, it manages libraries. Okay. Now Python is the overall programming language that we have, and then this IDE, right? Okay. Anyway, this IDE is where you can run code, just like this one. This is an IDE. Okay, let's say under the hood these code blocks are getting converted to Python, for example. I don't know how it works. It is developed by MIT. So we have to contact them to understand what is happening beyond this UI. So whether these code blocks are getting converted to Python or C. But anyway, so this is what an IDE means, where you can code. and the IDE's job is to
So what is the full form of IDE?
integrated development environment. Okay, so what it helps you to do is to type or basically gives you linting errors. Linting means whenever you write something wrong, or let's say which is not allowed in a language, right? Let's say if space else is not allowed, or for Python, let's say you have to do a colon whenever you are doing a code block. So if you don't give them, it will give you linting error. So it will highlight, okay, this part of the code seems incorrect. So that's the work of an IDE. What is another work of an IDE, or let's say another set of works of an IDE, is to give you a, let's say, easy to compile or easy to run interface. Okay, so that you don't have to go back and forth to the terminal. So basically the executing capabilities and the editing capabilities, wherever these two things are there, and then let's say debugging capabilities as well, then it is called an IDE. Okay, so it's a development environment. Okay. Now if you don't have Python in your system, so just go to this URL, and so what I can do, I can share this presentation with you now, right? Wait, share. Anyone with this link can view. Fine. Hello. Wait. Chat.
Which one it is? App Inventor.
Anaconda. Yeah. So I have just shared the presentation link with you in the chat. So you can just go to that presentation and see these links. You'll get it from there. Okay.
Okay, sir.
Okay. So you can just go to this link and download the distribution, which is like according to your system, right? So I use this distribution which is for Mac. So if you have Windows or Linux, there will be distributions for them as well. Uh, just open or download that distribution and install it. So it will be useful for the entire period. You can code or debug program, ask queries like hands-on, right? Whenever you are doing, and I am taking a, let's say, tutorial, so you can directly ask, okay, this is where my program is crashed. You can share your screen and so on. Okay. Okay. Let's.
Anaconda is also free, no?
Yeah, it's free. So you can go to the community edition. So there are two editions, enterprise and community. Okay. Now this distribution free download. Resources. Let me just. Oh, their site has been changed. A bit. Wait. Wait. Provide email address for the distribution. Free download. Okay. Let me just. Okay. Yeah, that's free download. Okay, so they have, I guess, made some changes, okay, in the download policies. So you have to email them, and then they will give you a download access. So what you can do instead, there is a variant of it, Miniconda. It's free. Miniconda is free. Download Anaconda anyway.
Sir, we
So
can do this without giving email.
without using, or you can also
Without
download it
using
with the.
email.
Okay, let's just check. So anyway, Miniconda would also work to Anaconda. Okay, free download. Now I can
Just
do submit.
keep the registration. Keep the
Oh, sorry.
registration.
Oh, sorry. Yeah. Okay. Okay. So anyway, just keep that registration and just download it. Okay, because that would help. So there are Windows version, Mac version, and Linux version. If you install according to your system, and then later, if whenever you face some, let's say, error, you just share your screen and show me. Okay, we are facing error there. Okay. Fine. Okay. So our recording is on, right? Yeah. Now let's go to next slide. So what is like I don't think we will be covering up to here. So we have half an hour now. So we'll cover basic things of Python, okay? And let's say do some exercise. So so you like, positively install this ID so that you can code along, right? Later on we will be, let's say, doing some practice problems, or let's say you ask some problems to solve, right? You can also code it along with me. So definitely install this ID, and this Jupyter Notebook ID comes within Anaconda, so you don't have to install it like separately. It will come within Anaconda, okay?
Sir, then what is the difference between Anaconda and the Jupyter Notebook? Both are same.
Oh, no. I said it right, that it's a manager. So Anaconda is a manager. So that manages everything. Your packages, your Python version. So there are a lot of Python version, right? So you can have 3.5, 3.6, 3.9, and based on your utility actually. So on, let's say you want to run a specific package, a specific version of a package, let's say TensorFlow 1.2, then you have to have 3.6 Python 3.6 installed. So now you have your system, so you cannot reinstall Python 3.6, right? So this manager, what it does, it can help you manage multiple versions of Python and libraries together. So this Anaconda is a manager. this this works on Python and R. So I am just, for now I am taking R as an example, Python as an example, on which you can code with Anaconda, and then ID. This ID is installed with Anaconda. So you can code in Python in Jupyter Notebook, which is being managed by Anaconda. Clear, right?
Ah, yes.
Yeah. Okay. Now let's go to today's agenda. So our agenda for Python. So Scratch part is over, and we already learned some basic blocks. If you have any queries further, so you just uh, you can like write it somewhere down, and then later session or next session you can discuss them. Okay. But for Python, we'll try to cover some part of today's agenda. Let's say the primary data types which we have, what is variable and how it is different from C, first of all, and how we can take input output. Operators and branching will, if I can cover, that is fine, but if I don't cover, then we'll move it to next session, okay? But anyway, for till the end of this session, you will be able to make Python like print out your name at least, okay? So you input your name, it will print out your name, let's say, okay, or do some addition or something. Okay, so let's go. Okay, so the primitive data types are this. So in C, so in Python we have 1, 2, 3, 4, 5 primitive data types, which is none type. None type I will explain it later. What is none type? None type is similar to void in C. So in C we have a void thing, right? This void that means nothing, right? So for Python, similar construct is none type. And then we have integers, we have float, we have boolean variables, and we have strings, right? These four things, I guess any programming language on earth would have, like only the scripting languages, right? Not the markup languages. So markup languages, by what I mean by markup languages, is HTML, right? Or let's say this TypeScript is sometimes used as a scripting language anyway, but HTML is a markup language, or let's say LaTeX. Somebody is okay. So fine. Um, so anyway, the scripting languages, they will anyway have these four: this int, float, bool, and string. But the markup language, yeah, I cannot hear you. Just repeat once. Hello, hello. Okay, just unmute yourself whenever you are having any doubt. Okay, fine. So yeah, so for C we have void, but for Python we have none type, similar thing. But this is what is different from C. This abstract data types. So how many abstract data types are there? So list, directory, set, complex. Let's say there is another list comma tuple. What we can say, we can have list comma tuple in the same thing. They are different, but anyway, for now I can keep them in the same block. They kind of represent arrays. Let's, fine. So now for primitives, it's still easy. We'll say how they works. Abstract data types, this list and tuple, they represent arrays. Dictionaries, they represent map. So if you know what is map, in C there is this standard template library, right? That implements all these abstract data types, vectors, maps, hash maps, and all. So dictionary can be seen as a hash map kind of thing. So it has this key and value structure, key value. So whenever you enter a key, you will get the value in return. Set is set as usual, so there will be no ordering between the elements, but it will represent a group of elements, right? And complex are, let's say, uh, xi plus y, right? These kind of things. Okay. So data types, we are clear. We will explain each data type separately. Now, ADTs we will discuss them in detail. So they will be very useful for a lot of applications, for AI applications, right? Or let's say for analytics. These abstract data types are the key to manage your data. Okay, you cannot do anything with primitives, but learning primitives would work because abstract data types take primitives as their members. So let's say a list, right? It can be a strings list or it can be a floating point variables list, right? So first of all, learning primitives would help, and on top of that, ADTs would help you to manage your data. Okay. Now let's go for what are kind of some exemplar values, right? Let's say for int, I have 1, 2, 3, minus 10, all natural numbers, 0, even 0, and it stores up to this value. So Python cannot store beyond that. Okay. Oh, sorry. Yeah. So up to this value, Python can store easily, theoretically, but sometimes some IDs what they does, they increase the allocation size and go even further. So you can store number even further. Okay. But anyway, theoretically, this is the upper limit on Python. So I guess 21 bytes or something. I have to check. Okay. Anyway, these are irrelevant. Maximum number. Uh, yeah. Now for float, these are some examples. You already know them if you know C. But if you are a, let's say, first semester student, then this would also help you in your C exam. What is a deep example of a floating point number, right? Okay. So these are the set of real numbers. So integers are the set of natural numbers. Floating point variables are set of real numbers or or let's say fractions. Now Boolean can be true and false, and this capital T and capital F is its case sensitive. Okay, so you cannot write small FALSE is false. So you have to write capital FALSE. Okay, or true capital TRUE. So that's something Python would only identify a particular thing as a boolean if that first letter capital true or capital false is there. If you write small false or small true, then it will not work. Okay. Now string. So string can be anything like hello, right, or your name. Now none type. So none type means nothing. What is exactly similar as void in C. Okay. Now you can think of Python variables as a container. Okay. So it will be really helpful, or it will be very intuitive.
Sir, I have a query.
Yeah. Go ahead.
So why are we discussing these primitive data structures? I mean, are they used now?
Uh, see, so see, whenever you are building a house, right, then you have to build it brick by brick, right? So these primitive data structures will be used all over your throughout your career, throughout your whole whenever you are working in computer science, or let's say related to IT, right, this primitive data structure will be there always. So let's say even you are using a dictionary, right, within that dictionary, let's say the key value is the string. So you have to know how to manipulate string, otherwise you cannot change a key, right? So you have to know how to, let's say, use integers for something, let's say to or let's say break an integer to its member, let's say 1 2 3, I want to get 1 2 and 3, right? How you can do that? What is the efficient way of doing that? So knowing all those things would always help, because anyway these abstract data types or this uh, yeah, those are actually made from this primary, like this primitive data types, right? So those are, you can think of a big dictionary is like a house, and within that house these integers, strings or booleans, these are actually bricks. Okay, so knowing each and every brick would be good for how you have to manipulate the data you don't know, right? Let's say you have a dictionary, you want to, and dictionary, let's say you have a dictionary like this key, your roll number is the key, and then your name, your class, those are the variables you are getting from the key, right? That's the value. Now I want to change your class. You let's say you passed 12th and now you are studying in first year or second year, right? Now I want to change that. Let's say you have earlier you have 12th, right? I want to change it to first year. So I want to know how to manipulate a string, right? So that's the main objective why you are learning primitives. After that, whenever we have say complex data structures like dictionary, list and all, we will be it will be very handy to know how to manipulate in data structure.
Okay, thank you, sir.
Wait. So one of my friends just come by. Okay, so so yeah, so how it is different from C? So for Python primitives, right? How it is different? For C, I have to strictly define what is the type of that variable. So that's where things get changed, right? So for Python, I don't have to define the type of the variable. So let's say I want to store an integer, A would work. If I want to store a float, same A would work. If I want to store a boolean, then also the same A would work. Okay, a string also non-type. So what it means is Python treats variables like a container. Okay, so like a balti or something, right? You can put anything. You can put let's say water in it. You can put milk in it. But for C, you have to define this is a balti which is for milk. But for Python, you don't have to define it. You define a container, or which is called a variable, and you can put anything within that variable. Okay, so that's a really a crucial concept of Python. You don't have to define the variable type or what it is storing. For C, you have to define that's an integer type variable, int a or int b. But for Python, you can just write a equal to 3. So it will okay, it's an integer type variable. Let's just do it as I'm saying. Let me open up my terminal. Right, let's fire up Python. Now I'm not using Jupyter Notebook now. I'm using the terminal the Python version of the terminal version of the Python anyway, but you can use Jupyter Notebook if you want. Okay, now I define a variable called a. So you can see my screen and read the variable name, right? Or I have to increase it. Let's just increase it. Now you can see.
Yes, sir.
Okay. So let's do a equal to 3. Now I want to check what is the type of that variable a. So that type, this is there, type a. So it's an int. Now let's say I use the same variable and I change it to 1.23, and I see type a is now float. So you see the same variable, earlier I used it as an int, I can use it as a float now. So I can also use it as a string. And for Python, strings can be defined with single quote or double quote. Let's say for C, right, you don't have to, you have to define characters in single quote and strings in double quote. But for Python, there is no restriction. So you can use either single quote or double quote. Yeah, now let's see type of a string. You get my point, right? So how it is kind of a container like thing. Okay. Now casting. So any data type can be casted to any data type, but you have to know how they get translated to it. So if I convert, so logically it doesn't make sense. So if I convert a string to a boolean, what would happen? So there is no logical conversion of it, right? So you cannot convert a string to a boolean. But we choose a construct, we choose a casting key. Whenever there is a string which is not null or which is not empty, then it will produce a 1 in boolean or 2 in boolean. And whenever you have a string which is empty or doesn't have any characters, it will convert it to a false. These kind of tasks, the casting, this is called type casting. Okay, and it's used widely in Python. Like really rigorously we use typecasting. Okay, so let's just try it. Let's say I have string, oh sorry, a is a string now, right? Yeah. Now let's say here, fine. A. Now I want to cast it to boolean. So how I can do it? Bool of a. See, it's a true, right? Why? Because a is a string which is having characters. Now let's go for a string that is empty. This is an empty string. So you see there is no character between the double quotes, right? So now if I write bool a, it will give you a false. So these type of type conversions are really important. So int C, int can be converted to float, but with penalty. With no penalty as such in terms of value, but in terms of memory footprint, it will take more memory because you have to represent 0.000 these things, right? Let's say you have 2 in your integer, right, and then you convert it to float, it will convert it to like 3.0000000 lot of zeros, right? You are converting 3 to 3 float, 3 int to 3 float, then it will take more memory. However, when you have float, let's say 3.0000 there is there, you convert it to int, it will reduce memory, but there is a catch. Whenever you have fractional points, right, let's say 3.02356, and you convert it to an integer, it will the decimal parts will be missing in the integer, right? It will only get 3. The fractional part will be lost from the data. What I mean by that, there are benefits as well as penalties of typecasting. So you have to know, or you have to beforehand understand what would happen if I do this. If I apply this typecast, if I am whether I am saving memory or whether I am losing data, you have to like know that beforehand. So let's say I have an integer 1 or let's say 2. I typecast it to a float, and see I am also showing how you can typecast every data type. You can just remember them. Okay. So float, this would give you a 2.0. So now this 0.0 is extra. So the memory footprint has been increased from an integer. However, let's say I have an float 3.0. I convert it to an int. It will give me 3. So this 0.0, so you don't have to represent this decimal places in memory, so that memory footprint gets reduced. However, if I have something like this 3.123, something, anything. Now A is that if I cast it to an int, yeah, my memory footprint reduced, but this whole data, it gets this one get lost, right? And like I don't know how, like whether you can realize how big of an impact that would make, um, but this would make a lot of impact on your application. Okay, so even this point one is a big deal in computing. So in overall computing paradigm, so it will be like, so you have to make correct calculations. So if you fall into rounding of errors or these kind of truncation errors, these are called truncation errors. Okay, rounding of errors are like when there is a variable which cannot fit in memory, so the computer will just round it off to the maximum representation it can store. That's called rounding errors. Okay, and these are called truncation errors. So the whole decimal plus part gets truncated directly. And rounding errors you can also try. So a is this, I can just do round on this round, so it gives me 3. But you can also pass how much decimal places you want to round. So let's say I want 2 decimal place number, I can pass here 2, it will give me 3.11. so these are called rounding errors. Okay, let's say I have a variable called a equal to 3.56. If I want to round it to 1 decimal place, it will give me 3.6. Got it, right? Now into float I can do it, into boolean same thing. So if you have 0 it is false, otherwise even if you have negative, then also you uh, then also it's not like true. So the thing is this: if you have a 0, a equal to 0, and it's an integer, if you convert it to boolean, it will give you false. However, if you have anything which is not 0, let's say -1, then also it will get you a true. If you let's say have 10, then also it will give you a true. Conversion, fine, you understand the integer only 0 is converted to false, fine. String you directly get it, right? A equal to let's say 1 2 3 4 5, this stra, it will give you that string. Okay, fine. Float to integer, you already know there will be a truncation error. Float to float, not necessary. Float to float is necessary, let's say that's rounding, right? So I can convert a floating point to a floating point, controlling its rounding parameters. Okay, I want 2 decimal places of that number. Now
Sir, in what
boolean,
platform you are using now?
yeah, repeat again.
What platform you using now?
So this is called IPython. This is called IPython. So that is like handy to use. That's why I'm using. But anyway, let's show you what Jupyter Notebook looks like. Uh, let's say make a directory there. Uh, now run Jupyter Notebook on this. Jupyter Notebook. This is called Jupyter Notebook. Okay. Now how I can create a notebook is by clicking this new button. See this part. This new is there, right? Now I can click
So
and
I have a query. So Google Colab and Jupyter and
same.
Anaconda. Okay.
So Google Colab is exactly same as Jupyter Notebook. This is an offline editor, so you can save
Okay.
your code in your device. That's why I'm using it. Uh, yeah, but for Google Colab you can use it if you don't want to install the interpreter in your system. But anyway, you are
So
in
like
computer science, right?
actual researchers when they work on, so they won't be working on Google Colab. They will
No,
be working.
no. That there is a catch. So see my laptop, how many, like how much RAM it has? Let's see. It's 8 GB, right? Right. So nowadays the models are, or the machine learning models, they are already more than 100 GBs, 400 GBs, 500 GBs, right? So I cannot possibly run anything on my laptop. Okay, so what I do, I use a server. So we don't run it on Google Colab, because Colab give you limited access, right? You can give you 25 GB of RAM, I guess 25 GB of GPU memory if you are using free, and if you are going for a subscription, it can goes up to a limit. It doesn't go too much, right? But for us, we need 1000 GBs of RAM, let's say 100 GBs of GPUs. These kind of stuffs we need for research. So what we do, we use servers. So we have servers deployed in our, let's say in the department, or in remote locations. Like let's say I have some collaboration with some university. They have also deployed some huge servers, so I can access it remotely and run code there.
Okay.
Okay, so that's happened via terminal, obviously. You can also use a Jupyter Notebook instance there, access it from there. But anyway, we don't run code on local device for research. And Colab is useful to some extent, but when you don't have too much resource requirement, however, it's limited. It's like Google would only allow you to use a certain resources, right? Like up to certain limits. Beyond that, the cost of using those resources will be really huge. Okay, better to have your own infrastructure so that you can run your code throughout the day, throughout night, and every time, right? But anyway, so for you can go with Colab. So because you are just learning Python at this point, no need to, like, there is not a strict requirement of installing with this IDE. You can always code in Colab. But for research, you have to go with hardware, own hardware, or some powerful server. Okay, so instead of coding here, I can also code here. Okay, same thing. A equal to 2, type of A, integer. Same thing, these code blocks I can run again. So let's say I change it to 3. Let's say I change it to hello. Fine, right? Okay.
So when I open my Jupyter, then we go to the new section. Here some option like notebook, template, like that. So what I click, where I click, just notebook.
Yeah, here you click on this notebook, and anything which comes like down, like below that notebook. Let's say I have this two Python version installed, so I click this one. So anyway, you have only one Python version installed, right?
But
So
here,
just click.
here just
There
notebook,
will be a
note
Python.
down or nothing.
Oh, okay. So you can share your screen once. Let me give you sharing access. You are, just here, raise your hand once. Anis, right? Oh no, Rajdeep. Rajdeep, wait, let me. Rajdeep.
Sir, I am not in. I am doing the class from my mobile, and
Okay.
I don't do this in laptop.
Okay. So I guess either you don't have a Python version installed. Okay, then you don't get to see this type of thing. So you are supposed to get this type of under notebook. You have to see this Python 3 or Python 3.6, whichever Python versions you have. Okay, so
Do
after
I
you
have to
see
download any
this,
Python version? I don't download
no,
anything until now.
install Anaconda. That's it. Anaconda will
So I
install
install
everything.
Anaconda.
Okay, so you cannot see. Can you click new, and then can you click on something? Not this other.
So
The under notebook.
after clicking notebook, then the front page you shared that come.
This one. This one.
Yeah, this one.
Yeah, this is the notebook. This is the ID. So you can name it. Let's say
Okay, got it.
my program, right? And you see now I am running. This is my program. A and then type of A.
Okay,
Got
yeah,
it?
got it.
Okay. and it basically generates this ipynb file. See this my program.ipynb, this is my program. When let's say I want I code up to let's say 100 lines today, I come tomorrow and then code next 100 lines. Okay. Okay. And these blocks, what they represent is this set of instructions will be executed at once. So I can put all these things together, let's say multiple persons, let's say hello, bye, and all those things. They will be executed at once, and the last line's output will be outputted. Let's say I can make it 3 or 2, only it get outputted because this gets lost. This doesn't get output to the output console. By printing that deliberately, I can have it printed. Print though, so the print function is used for output. Okay. Yeah. See, first one is string and then second one is int. Fine. So you now know how to use the IDE. Where is the slide? Where is the slide? Oh, here. Okay. Now the type conversions, you already understand the type converts have their pros and cons. You can optimize memory sometimes, or you can basically approximate a data so that it's not useful anymore, right? So you can also lose the granularity of the data. However, okay, anyway, leave it. Typecasting, we'll touch upon this later on the practice questions. Now the arithmetic and logical operators. So now the arithmetic operators, see, plus is represented as normal plus, fine. Minus, multiply, fine. Now divisions have three types actually. One is this float division, this integer division, and the modulus or the remainder division. And the power or to the power is represented in Python as star, which is in Python you have this pow operator, right? POW. In math, if you import math, you can call POW and then let's say 2 to the power 3 you can compute. But for Python you can only use star. Let's say 2 star 3 means 2 to the power 3. Let's just check them once. Where is the here? So 2 plus 3, 5, 3. Oops, sorry. 3 minus 2, 1, 2 into 3, 6, 2 to the power 3, 8. So now this is power. Okay. And now division, that is interesting. So I have 10 and 2. I want to divide 10 and 3, let's say 3. This is a float division. 10 divided by 3. This is the float division. So I will get floating point as output. 3.33333. Fine. Now integer division means this. Oh, sorry, this. So that means I will not get the floating part. I will only get until that is completely divisible. So I will get 3. This 0.33 part is not there. Why not there? Because it's an integer division. Now I want to have the remainder division. So how much is remaining? 3 modulo operator 1 is remaining. So you see why this 333 comes, because I have this 1 divided by 3 remaining, right? So that's why in the float division this 0.33333 all these things come. Okay, and see this is an error, you see. So here I have 3.3333 and then last we have 5, but for 1 by 3 I have plus 3. How it is possible? So if I just take a negative from here to here, oh sorry, let's add 3 here, or let's subtract 3 from here. So this is the error I have. If I do 10 divided by 3, which is 0.3333 is represented like this, and 1 divided by 3 is represented like this. In both cases I have, in Python I have this error, so which is obviously greater than 0. See whether, let's see whether it is greater than 0 or not. True. So the same number can be represented differently in Python. These are called like these happen due to hardware approximation. So how you are exactly storing that number, okay, in the memory, how it is getting stored. Based on that, it is actually there will be lot of cases where this type of errors can come. Okay, so we'll discuss it later on as you go forward. We can discuss it later on. Okay. Okay, the operators are arithmetic operators are done. Now let's go for comparison operators. So you can have greater than, less than, equal to, not equal to, greater equal to, less equal to. These are exactly same as C. So whoever has like attended C classes for the first or second semester, they can directly apply it here. So yeah, so let's say 1 greater than 2. Oh sorry, where is right? Yeah. 1 greater than 2, it is false. Yeah, it is indeed false. Fine. Arithmetic operators, and then there are logical operators. So in C you have double this 2 ampersand to represent and, right, or 2 pipe symbols to represent or a exclamatory symbol to represent not. Here you just write it as normal words, so and, or, and not. So let's do this or truth table. Or truth table means what? Whenever there is a true, it will be true, right? So let's do true and true. Output is true. True and sorry, no, or we are doing or truth table. True or true. True or false. For true, because there is a true, right? True, sorry, false or true. True, because there is a true. False or false. False. Only when both of them are false, this is false. Now let's similarly I can do a and table true, false, false, false. Right? When both of them are true, then only it will return true, otherwise false. And this not is a unary operator, so it works on only one type. So these are binary operators, right? This it takes two variables, operate on them, and gives output. Wherever this not is a not false means true, or not true means false. Yeah, but this. Oh, sorry. This reminds me of some joke, right? This why it is not true. Explain why it is not true, because it is not false, right? Okay, fine. Yeah, I guess we are here over time now. Uh, what are the topics still left for this part? I already know some bit. Yeah, so there are a lot of stuff remaining for next day. I'll just mark something here. Key up till here I have completed. Let's have a shape here and color it as green. Oh, sorry. I have to color the field color as green. Yeah. So this marker will represent up till which part we have progressed. Okay. Later on also. Uh, yeah. Okay, guys. So I guess I guess we can close this call now. Uh, I hope you understand everything, right? So you can just unmute. If you have any question, you can unmute. Okay. Thanks, guys.
Hi, sir. Good evening. I just have one
Good.
question regarding examinations. So, will it be like an MCQ based paper or like a written exam or a computer based paper? Like, how's it gonna be?
So I guess there will be MCQ based, and so what happens usually. So I have not seen how this Python course set exams, but earlier I was TA in networks course, one of the networks course in NPTEL. So there the question pattern was like this. So you have a set of questions which are MCQ. You have a set of questions where you are where that is numerical. All of them are kind of MCQs, but their marks distribution is different. So you can have like MCQs that are 2 numbers, or let's say numericals that are 4 numbers, right? So anyway, so the thing is, all of the questions will be MCQs only, but their marks distribution can vary. So let's say some question can ask you to say ki whether this code block is correct or not, or how you can fix it. What, let's say it gives 4 options and kind of ask you ki okay, which option would be able to fix this code. Or let's say it gives you a code, and so okay, what will be the output of this code? These type of questions will be little bit on the bigger or the higher margin or higher numbers. However, in let's say how to see type of a variable, this type operator, right? So, yeah, those are usually less marks questions. But
Okay,
anyway,
thank you,
I
sir.
will, yeah, so I will actually see some of the previous year questions and let you know later on what will be the exact question pattern. Okay. Okay.
Sure.
Okay. I guess we can close this call. Yeah,
Excuse me, sir.
nice to interact. Yeah. Go ahead. Go ahead.
Hello.
Yeah, I can hear you. You can speak.
Sir, can you just share the slides, or maybe you can give us link to the slides so
Yeah,
that we
it's
can refer?
already in the chat. It's already in the
Oh,
chat.
okay,
Yeah, I
okay,
can.
sir.
Yeah, so I guess the recordings will be also available in the chat itself.
Okay, okay, okay. ठीक है, sir.
I will upload it to YouTube. You can also visit my YouTube channel. So if you want to revisit the
Okay,
whole interaction.
fine.
Okay. Okay. Thank you, guys. So it's really nice to interact with you all. See you in the next session. Okay. Bye. Let's just stop recording.